the control plane edition. We are doing a mild takeover, giving you some insight into what we've been doing recently and some of the presentations that we put together at KubeCon. Thank you to everybody who's turned up today. Good day and good evening to everyone on the live stream, wherever you are in the world. And I'm pleased to introduce my fabulous, erudite, and devastatingly effective penetration testing co-speaker, Mr. Ian Smart. We will talk about persistence and escalation in Kubernetes, what to do, what not to do, and where it all goes wrong. And yes, with that, let's get started.
Do we have a magic working clicker? We're plugged in? We do not have a clicker.
Oh, in that
Oh, is that you? I thought it started working. In case you haven't worked it out yet, this is us. I didn't bring the cat. I would have quite happily brought the cat. She doesn't travel very well. She's a little bit bigger than that. Andy, I think you've walked out of frame.
Oh, I wasn't intending to be in frame, but
look, we've even got a handy thing to show us where we are. Yes, introductions I think we've done. I'm Ian, this is Andy, just in case we haven't done it. The shortest introduction you've ever had.
Very good, yes.
So yeah, we're going to talk a bit about what OffSec is, what offensive security is, some common findings that we see on penetration tests, because like with anything, we see misconfigurations come up again and again fairly regularly. We're going to do some demos, which are pre-recorded. We're going to see how well this platform lets us jump to them. We'll see how it goes. Talk about some post-compromise activities, which is the stuff that I find most interesting here, and then another demo if it works.
Right, I think it's working.
Nope.
Okay, I'll just wave it. Right, of course, we know and love the Borg overlords Kubernetes. It is the distributed machine to which we offer our hopes and dreams. We pray for reconciliation and hope that eventually it gives us the state that we desire. Of course, Kubernetes is complicated, but the reason for that is that distributed systems are complicated. And we moved from a place where we could run a lamp stack, where everything sits happily tenanted on a single machine, into somewhere that gives us elasticity. It gives us the capability to run in a distributed manner, so we're running more complex applications, and it gives us things for free. We get things like service discovery, which is classically not that easy. You've got questions if you're going to run DNS, like how do you do the TTL, who's updating this? So Kubernetes gives us these useful primitives that abstract away a lot of the complexity inherent in building a resilient system, and of course, cloud native, built for the rented and instantly API-driven scalable architectures. However, the complexity in the problem space is expansive because we have YAML for every single thing that we could imagine. This results in the possibility of misconfiguration. No, really. So obviously, we have the number of moving parts. We start off with, it's a Linux box. We're using Linux kernel APIs to build namespaces and unshare processes into them, to contain things with Linux security modules, capabilities, the core kernel security functions that we have around a process. On top of that, we have the container runtime that gives us a developer experience on top of it. And then we get into the kubelet, which is now managing those runtimes for us, plugging in our network interfaces, talking back to the API server to deal with resilience and essentially restarting or redistributing workloads. And then, of course, security on top of that. How do you lock down something in a network namespace? How do you architect your pod for resilience? How do you configure the container? It's just a microcosm of Linux to prevent somebody escalating from remote code execution into owning the container and then beginning to attack any of the capabilities that it has. Capsysadmin, we've seen various container runtime breakouts around proc self-exe. There's plenty going on there. And of course, the rapid changes. Not only do we have beta APIs persisting for many moons that suddenly break your cluster when you forget to update them, but also the release cycle, the fact that for many moons, people tried to update Kubernetes in place and it would break in unusual and often obfuscated ways. The operational requirements of running these things, actually, it is not about how do I run this personally, it's about how do I reorganize my entire organization into the relevant responsibility verticals that will manage the actual clusters. the running of the applications, the managing of the tenants, the observability that goes with that, security, the security monitoring. All of those things change from people running the microservices in isolation into the large distributed managed version of Kubernetes that we tend to run. And of course, security is a cross-cutting concern throughout all of these things. Ta-da! So the best way to secure anything is the Sun Tzu art of war mentality. You attack yourself so that you understand what your adversaries have access to, what they can see, the visible horizon, and this is ControlPlane's raison d'etre. Do you think you're secure? This is one of Ian's favorite things, of course. Let's validate that assumption. This is why red teaming and an inner focus, taking an external perspective on a system that you own, is so valuable. And we'll talk about how red team and purple teaming kind of cross over. Ultimately, this is an analysis of a system which is assumed to be secure against the visible configuration horizon, let's say. What happens next? Purple teaming is the process of integrating your blue and your red teams. In many ways self-explanatory. The difference might be a red team classically operates with no boundaries. You pretend you're outside an organization, whether or not you work for the organization or not, and then you can perform social engineering attacks. You can drop USB sticks in car parks. You can break into people's homes, depending upon what you've been signed off.
Generally frowned upon that one.
But I mean, if you listen to Darknet Diaries, for example, you'll hear red teamers who are doing these things, and they're always sanctioned by the client. These are not illegal activities. Perhaps breaking into someone's home requires a special form of sign-off in a specific country. But nevertheless, red teams operate in a very specific external-facing, you call it a black box perspective. Whereas purple teaming says, well, we've already got a lot of institutional knowledge. The blue team have analyzed this platform. They've considered the risks. They've tried to secure it all the way through. And they may have concerns over specific areas of the platform. So a purple teaming operation is not only taking that blue team knowledge and feeding it into the offensive team, but it's also the red team or the offensive team collaborating and working back and saying, for example, if I can perform these attacks and you blocked them, does your security operations center actually know? Did you get the right alerts? Have you got the Christmas tree experience when I've performed this particular action? So it's collaborating throughout the organization across different types of teams. It's making sure the monitoring team in the system and the security operations center have the visibility that they need, and this test detection coverage when we're performing these pen tests. Do we have the detection for all of the actions that have been performed? A useful way of modeling a system and an enterprise security architecture is to assume that each and every application is already compromised. This means the topologies that you build out, the credentials that you give, the way that the network is segmented, and the way that access and applications are delineated and deployed are from a position of, well, this socket faces the internet. Somebody is going to get remote code execution into here. What happens next? Well, they've got the credential of the process. What can they access? So it's the principle of least privilege on steroids across all aspects of the individuals and the technology that builds the entire application. So in this case, from an internal breach perspective, if I'm one of the system operators, if I'm an SRE and I've been compromised by a nation state or by
checking your credentials into GitHub by accident.
Yes, precisely, then what happens next? What can I do as the platform owner to prevent that individual or that credential leak from having existential business ending side effects? So some of the common findings that we see on tests.
Yes, there are quite a lot of these, I think it's fair to say. We're going to go through some of them. I'm really upset that the emojis I put in here don't show up. I had a water pistol emoji and a foot emoji. A foot gun, for those of you who haven't heard this, is basically a piece of functionality that means you can easily shoot yourself in the foot. The next slide will show you why I introduced this now. Hopefully some of you are familiar with Kubernetes RBAC. It works. We'll be positive, it does work. There are some problems with this, I think it's fair to say. a lot of people still make a lot of mistakes when they're assigning permissions in Kubernetes. Anyone here who's tried to do this at scale or in a multi-tenanted environment hopefully knows how difficult this can be. My personal biggest complaint is the fact that there's no concept of deny built into raw RBAC. You need to use an external authorizer. So if I've got a really, really secret that I want only my admins to be able to get, but I want someone else to be able to get all of the secrets, I need to give them explicit permission on every secret, but no, not that one. There's no way of me actually saying you are not allowed to speak to this one. And also administrators make a lot of assumptions which lead to escalations. I think the next slide has a few of these listed. The big one is secrets get versus list. I had an engagement a couple of weeks ago where the customer said, oh, it's fine that we let people list secrets because they can't get the values. This is a really common misconception. If I can list secrets, I can list all of the secrets, and it's not just the names, it's their values as well. Pod creation, I think anyone who's done any offensive security work in Kubernetes probably knows how easy, without something like pod security admission, it is to just take over an entire cluster by being allowed to create a pod. Another nice trick that I like to use is if I know the name of a secret, even if I'm not allowed to read it, I can create a pod that uses that secret and then just prints it out in my logs, which a lot of people kind of go, oh, that's not great. Pipeline service accounts as well. We see a lot of people running Kubernetes pipelines and they say, well, we only give access to a very small amount of the pipeline. This project's only allowed to do certain things, but it's okay because we'll run the pipeline as cluster admin because it just works. Just like how for years people have been running things as root, running things as domain or enterprise admin. I wish we weren't still talking about this now, but here we are. And the other one is RBAC escalate. I see a lot of people give RBAC star because they assume it's just create, read, update, delete. So I want people to be able to maintain their own role bindings, but not do anything else. The escalate verb is included in RBAC's star permission. Escalate basically disables a hard-coded check that prevents you from assigning more permissions than you already have. So if I give you the ability to create a role binding and you're only allowed to get secrets and create role bindings for some obscure reason, and you try and create a role binding that lets you make pods, Kubernetes will say no, unless you're allowed to use the escalate verb, which I have seen probably on over half of the engagements I've done lately. This is something fairly common. This QR code is not a rickroll. I was tempted to put one in. This will take you to the RBAC Good Practices guide on the Kubernetes documentation. If you maintain a cluster in the wild, absolutely worth going and reading that because it's a list of all the weird things that people have seen and how it can end very, very badly.
Is there an Ian Coldwater quote for that last point?
Yes. Ian Coldwater had a wonderful tweet a while ago. We're all made of stars, but your RBAC shouldn't be. If you're ever at any conferences where people are handing out the right stickers, there are some brilliant shiny stickers with that quote on. It's excellent. Next slide, please. So we're going to try a demo here. We'll see how well this works. If not, I will tell you what the demo did, and I will upload a recording of this later.
What we do today, but even then it just feels like there's no, because ultimately the nice thing about the tree is it's hierarchical, which you think straight away, okay, that sort of makes sense.
It's all right, we'll just talk through what we've seen. So effectively, I've done a kubectl auth cani in a namespace, and take my word for it, that basically says you've got no permissions, it's the standard system unauthenticated. And I've got a file here that is a cluster role binding to cluster admin. So I'm taking the user developer and just saying cluster role binding, cluster admin. I've checked that into my source control. I've added that to my Git. My Argo CD should be trying to reconcile that now. And what we should see is an error, which I helpfully click. It's not allowed to create cluster role bindings. It's not allowed to create anything cluster-wide. This isn't Kubernetes functionality. This is built into Argo. So what I'm going to do is very quickly delete that cluster role binding because we're not allowed to make them. It's not working as an attack. Interestingly, I have a Git repo of just all of these attacker manifests that quite often I just fire in as soon as a customer says they've got Argo and just see what succeeds. So we're just cleaning up the cluster role binding because otherwise the sync will keep failing. And we will now create a role binding. So we're now making a role binding to cluster admin. A role binding to a cluster role applies all of the permissions to that cluster role, but only in a single namespace. This takes a bit of getting your head around. It's basically for templating. But very key to this point, a role binding is not a cluster-wide resource. It's in your namespace. So what we will see is Argo being allowed to create this. So we now have, within our namespace, star.star permissions on any resource. The good news is, in most admins' opinions, we're probably not too bad off here because it's still only in one namespace. So you can see at the top there, I've got star.star, but I'm not allowed to list anything from the default namespace. So I've got my permissions in, let myself in, nothing else. However, and once this is run, we will pause, please, because I don't think the rest of the demo, I think that's everything we need. Yeah, so basically, we'll let this run. I'll talk through it. What I did there was label my own namespace. Now, Kubernetes namespaces are kind of a namespaced object, but kind of a global object in terms of Kubernetes RBAC. One thing I learned recently is that if you're in a namespace and you have get or patch permissions on namespaces, you're allowed to label your own namespace. The problem here is a lot more customers are relying on namespace labeling to enforce security boundaries through things like network policy or pod security admission being the big one. I've also seen customers roll their own security through this. And they say, well, it's fine. People can do what they want in a namespace, but they can't modify the cluster because they're contained in this way. Unfortunately for them, this behavior means that if I've got star.star or just patch in a namespace, I can basically take over the entire cluster by breaking out from inside that namespace and doing, for anyone who's not seen this before, this is the most pointless Kubernetes command ever. It's basically a pod that's created and turns off all of the security. So this effectively says run as privileged, mount the host file system, mount the host process namespace, all of these nice bits of isolation, turn them all off, it'll be fine. Can you just play this again, please? And what we'll do is we'll apply this, and if I remember to do this in the demo, we're going to cat host etc kubernetes pki ca.key. Now that is the master signing certificate for all of the user certificates, among other things, in a cluster. If I've got this as an attacker, I can just take over the entire cluster. I can sign my own certificates as the admin users, and I've effectively compromised that cluster pretty much forever, or until the certificate expires, which is somewhere between 1 and 10 years, depending on distribution. I think most of them are down to about 2 years now, but that's quite a long time for an attacker to be in. Can we hop back to the slides? So that was just, do the thing. Yeah. So yeah, that was a very quick example of one attack that we've had quite a lot of success with lately. This seems to be a fairly common pattern, is people running pipelines as cluster admin, allowing devs certain access, but if the dev does something malicious, then unfortunately they get admin. The more interesting thing here to me is, what do I do after I've got admin? And this is something that a lot of people have kind of vaguely thought about and then gone, that's quite scary. I don't want to think about that too much. Next slide, please. So my first thing is, can you actually catch me when I'm coming in? If I do something malicious, hopefully you've got some kind of monitoring. You're using your auditing, you're using some kind of host eBPF-based something to get security alerts. But if you're not immediately seeing these alerts and actually actively blocking based on what you see, then an attacker is going to get in. If I really want to hide, even though this would be quite noisy, one of the first things I'm going to do is just disable auditing. If I get root on a master node in a self-managed cluster, I'll just delete the audit policy, and then you have no auditing. Another one I really like doing is for customers that do have auditing and I can't modify the audit config. If you're streaming your logs to another source, it's really fun just to black hole that IP. Or if you're doing like DNS based, so if you're streaming to like logs.domain.com, just modify etc hosts and set that to some IP that doesn't exist. And unless you've got a canary on your logs, you'll never notice that you're not receiving logs anymore. So first of all, can you actually catch me? And then even if you can, how quickly can you respond? I reckon most organizations are between half an hour and 30 days, based on my experience. I've had customers before go, hey, I've caught you, you're DNS tunneling. Like, yes, look at the timestamps. That was 3 weeks ago and 2 engagements ago. I've moved on. Well done for catching me, but I've got all of your data. So the other thing is, how can I persist once I'm in? Let's assume I get in. How can I stay hidden? There's a load of ways, effectively. There's so many ways that we can hide. Minting user certificates, so crafting a certificate for the system masters group. You basically can't revoke that certificate without re-rolling your entire cluster. Directly accessing etcd is a fun one because etcd access is not audited by default, and also if you can get in, you have complete control over the entire cluster. So etcd stores the desired state of a cluster. If I can modify that, I can either read all your secrets or I can create workloads. And you can do some really weird stuff. You can actually create pods. And if you mess with the combination of the path in etcd and the namespace value in the thing you create, you can actually create pods that kubectl cannot see, even though it will create them for you. Because like kubectl get pods in a namespace just does a direct lookup. The API server gets a string and then just converts that string into a path in etcd. So you can make things that are very difficult to find. And the same actually with node manifests here. So in self-managed clusters, the kubelet quite often bootstraps itself up, or the API server boots itself up on top of the kubelets. If you can write to this node manifest directory, you can do loads of really, really weird stuff. The only thing you can't do is use secrets, and that's to stop you mounting in secrets that you're not meant to have by just writing on the node. You can also craft service account tokens, create custom RBACs. So I've seen people create an account that looks like this system, like a kube system reconciliation controller manager service account. Probably looks like a legit one because there's so many of them in kube system anyway, but it's going to be hard to find. One of the things I do on audits is check the timestamps of all of the service accounts, because if you see that everything was created 8 years ago and something that's bound to very highly privileged roles was created 3 weeks ago, that's probably dodgy. And my favorite one, there's a brilliant talk from Ian Coldwater and Brad Geisman a few years ago at RSA, and I think they repeated it somewhere else as well, where they built a malicious admission controller, where every time you create a secret, the admission controller just sends that value off to them. So you go, I'm going to create this secret in my cluster, and suddenly your attacker has a copy of it. They then went on to actually create a K3S cluster as a daemon set inside the cluster they were attacking. So they ran a shadow cluster onside the one they were attacking, which as a persistence mechanism is just beautiful. That's spectacular. And then even beyond Kubernetes persistence, we've got Linux persistence stuff. So again, another helpful QR code to the MITRE tactics for persistence in Linux. Effectively, we're going to pretend Kubernetes on Windows doesn't exist, and we're going to pretend that serverless doesn't exist, because it's weird and it hurts my brain. So we've got things like cron jobs and dropping SSH keys, modifying the container runtime, implanting on attached cloud storage. Andy and I were talking about this presentation a while back, and I think you said, well, it's fine, I'll just destroy all the compute but keep the storage, and then I've got a nice easy backup plan. If an attacker thinks about it well enough, they're just going to tamper with files on the cloud storage as well, so that when you recreate your application, it loads in something malicious. So there's a whole bunch more. Obviously, I'm not going to go through every persistence technique that's ever been identified in Linux. That would take quite some time. The key thing to take away here, though, is how quickly this can happen. My demo for this is sadly slightly broken, but I have a script that will, actually, should we try it and see if I did have it on the recording? Basically, I have a script that does all of these mechanisms, and it runs them very, very, very quickly. So if you're an organization with an exceptional response time, say you can pick up someone breaking in within 5 minutes, and you go, right, they've done something bad, let's get them out. If you assume that I've managed to at least compromise one node, or worst case scenario, compromise a master node, how can you be absolutely sure that I've not done various persistence mechanisms in about 30 seconds? If I've exfiltrated your master signing keys, if I've put SSH keys on all your nodes, if I've done LD preloading on your Linux nodes so that every binary you run suddenly does something completely unexpected and not what it's meant to, what do you do at that point to recover? So as a kind of take home from this, the thing I like to get people to think about is, if you get this canary token that says, hey, someone's done something bad, alarm bells are going off, how can you be really sure that you can actually recover your cluster? I think the best bet is, unfortunately, burn it down and start again. The problem there also becomes, if I've compromised your cluster to this extent, every system that your cluster authenticates to, all of your databases, all your secret stores, potentially your Active Directory if you're using some kind of on-prem auth, I've got keys for that as well. And you really had better hope that your key rotation is up to scratch and you can do it very quickly and very automatically and get me out before then. Because the other thing is, if you redeploy the cluster and I've got a known attack path, what's to stop me just hitting your API over and over and over and just getting back in again as you redeploy? I would simultaneously love and hate to work with someone in this position. It would be terrifying and horrifying, but as a technical challenge, I think it would be quite interesting.
Wonderful. I hope that is sufficiently terrifying. So the upshot here, what is the worst thing that could possibly happen to an internet-facing cluster? Well, first of all, someone gets remote code execution, then they're able to escalate in a manner that allows them to drop one or more of these persistence mechanisms. And sometimes the persistence mechanism is also the root of attack. You drop a reverse shell, and that's the way you get in, and then you drop more. As Ian states, at the point that somebody has compromised the cluster, anything that that cluster has access to, either directly or transitively through other escalation or trust boundaries, is then potentially compromised. So the default answer in a financial services organization is, as soon as there's an indicator of compromise, ring fence that node. But actually, as we would have seen with the smorgasbord of persistence demo that we didn't get to see, well, actually, the compromise of the single node is potentially the compromise of the whole cluster, depending upon the level of access that somebody had. And then any secrets that allow you to then access the cloud account build back into this worst case scenario. If somebody can get in through a web-facing socket, root the cluster, get cloud account access, and eventually take over the organization, maybe just through misconfiguration or through potentially keys sat in S3 buckets. I mean, who would do such a thing?
Never.
Then you run the risk of the front door taking over the entire kingdom. So kind of back to the point here, this canary token is something that when accessed triggers, it's the Christmas tree security operations center effect. They're fantastic. I deploy them liberally. You can have them as AWS keys. You can have them as various other different types of token.
KubeconFigs.
Yeah, exactly. And they ping back to a central server or a central account. Unfortunately, the guys who wrote Trufflehog figured out the set of account IDs that are used. So there's now a way in Trufflehog to basically uncloak canary tokens. Because before that, you'd have to do an authentication, sort of an AWS, who am I and what can I do, simple token service call to see what the thing could do, which would trigger the token. Now they're kind of unmasked. So be it. If Trufflehog can do it, then presumably other actors can do it as well. But the point here is that this is the canary in the coal mine. And at the point this goes off, the exercise to undertake is, well, how many different systems did the compromised system potentially have access to? And how wide do I need to draw that net? And how many different systems do I need to burn? So ultimately, as with everything, nothing is entirely secure. Run intrusion detection, and then take out the flamethrower. And with that, thank you very much. Any questions?
We'll take a nice 10-minute break. And the question is?
Does Rowan have a question?
In the screenshot there, because the demo that you post, was that running as root? Because the YAML file was the
Yeah, so the node root YAML that I created is a Alpine container image that runs as root. It runs with the privilege set to true. It mounts the host file system into /host.
It has a reverse shell in it.
And there are many, many things you could do with it. In my case, I was kubectl execing, just to prove that I could get a script running. You could do a reverse shell. You could pipe data back out over some webhook of some kind. My favorite one at the moment is actually using Slack or Discord, because an awful lot of ops teams are using things like Slack to get alerts. So the cluster needs to send an alert that says, hey, something bad's happening. So they whitelist api.slack.com. They unfortunately end up whitelisting just api.slack.com, and I start sending things to my webhook instead, and I get all the data. So I mount all of your secrets in, base64 encode them, and then send it out to a webhook, and I grab the data. Or you can do the same thing over DNS or various other means. It's possible, but non-trivial, to isolate a cluster that has to pull updates and images regularly from the internet entirely. Because you can do like split horizon DNS at the network and organization level, but DNS, I don't think I've seen more than 1 or 2 clusters in my career that don't have some form of upstream DNS that I can tunnel over, or at least get some level of data through, which is quite fun.
Yeah, did the demo work in your talk at KubeCon?
The persistence thing did, apart from the webhook at the very end. So yes, there is a recording of this from, if you look up this talk title from KubeCon, there is a recording which does have the demo. I will also try to fix it and get a video posted on our site so that we can share it as well. It's basically just take all of those techniques. It's like touch this file, echo this into SSH key, like root SSH authorized keys, just that sort of thing. But the key point for that is just how quickly it runs. It's about 3 seconds. And no one is responding to a breach within 3 seconds. If you are, fair play to you. And also, can I have your time machine, please? Cool.
Right, we'll take a short replenishment break and be back in 10 minutes. I enjoyed shaking the clicker.
Yeah,
That was an emotional support clicker.
Yeah.
Because it's all USB A and USB-C one.
No, we haven't done.
Oh, I was just checking it's on, actually.
I did not check that.
They do the button to click, right?
I've actually put one down for use. Wow.
Yeah, I have one of these as well. I'm now looking to get
So I went to buy one and I realized I do have 0 on it, and it does the exact same thing. So there was no point spending more money when I already have one useless gadget that sits on my desk and doesn't get enough use. You mentioned saving money at fair breaks. So we had a 13-year-old coming to jump in.
Oh, nice.
This is Susan.
Right, still got
Ashley, but
make it a bit more complicated. So I'm seeing the sound. Oh yeah. I think it's now about yes, so Okay. Actually, I want to revise what actually here. Yeah, that was it. Okay. It's not heavy, is it? Yeah, exactly. So my confidence is This is not working.
Absolutely awesome talk.
Yes, this is nice. Okay. Rory and Gary. Yes, so I will try to get at least the end of London is out. Why are you So I'm basically different.
Well, there's also
The other steps actually. The problem is, well, that's the concern with penetration, is that what they might hold the trend. So if I get access to and the persistence of most at that point is to write up all the documents, and there you go. It's not very much what it was. Oh my God, it's Yeah, sorry. That's what it's not. You're getting it. No, that makes sense. This is really cool.
I think it's
Oh. And another technical suggestion.
it's leaking.
Are you actually
This is
using the
live stream.
microphone?
Yeah. Because you can have one of these lapel ones. Excellent.
The anticipation builds. The trepidation crests. A very exciting next talk, I will reassure you.
Aha. To jump right into halfway through.
Wonderful.
That's quite exciting. And thank you very much. My name was Ashley.
Hooray. Well, welcome back. The next talk we have is global honeypots for Kubernetes and open sourcing the threat intel that comes from them. This information tends to sit with big hyperscale, but not the cloud providers, but Mandiant, CrowdStrike, people running threat intelligence at a huge scale. And we're going to talk about how to do this in an open source, distributed, and not only is the content open source, but the infrastructure and threat intel. And I pass you over to ControlPlane CTO, Ashley Ward.
Thank you. Thank you. I don't have the emotional support clicker, but I'll just, can we get the next slide, please? So who's this guy? My name's Ashley Ward, or Ash Ward. I am the CTO at ControlPlane, yay! And I'm reaching the end of my 8th week at ControlPlane as a CTO, which is very exciting. I'm accidentally slightly security aware. I always say that I'm an operations guy at heart. I was a Unix admin. That's how I cut my teeth. I was an 18-year-old getting to say no to everyone because I had root, no one else did. After a bit of career jumping about the place, I then found out that security could say no a lot more than I could. So I went, I want to be those guys because they really got the power. And I went and worked for a container security startup. Did a whole load of stuff there. But that means that my background, as I say, is more ops, and the joking aside around the wanting to say no all the time was actually about how can we make things better for everyone. And so I soon discovered that actually there's ways of doing things better. I found cloud native made things better than the big old Sun systems I was working with. And then moving on to in security, it was like, that's a big blocker. So how do we make that not a blocker? And that's what excites me, is about how we can move on and make things better. So let's move on. So the Kubernetes Storm Center, dreamt up by a lovely lady, Constance, who works, or who is the head of the Austrian, g'day mate, the Austrian open cloud community, sorry. And what she'd recognized was that you can be building a nice application, you've got something that's running on a cluster, it gets threat modeled, and then everyone goes, oh, look, there's lots and lots of threats. There's lots of different vectors. There's lots of different paths. There's this path A, there's B. What do? You can't fix all of them. So you need to be able to judge whether A is more important than B and try and do that. And in order to do that, you would usually need to get really big organizations in who would then have to use their gut feel and a bit of, well, I've seen that attack before, so it's more likely that this one is important or that one. And so she went, there must be a better way of doing this that we can do in a more open and sustainable way. Do I do that? Do I jump that around when I move? Is that what I'm doing? No, I just keep seeing the picture change and I go, oh, is that me? Gosh, this does add weight to you, doesn't it? Yes, I know, that's what I mean. Bloody internet. But there were some major principles that she really wanted to conform to, and that's this idea that if you're going to produce something like this, it's got to be available, it's got to be easy to consume, it's got to be something that is ultimately should be free so that more people are doing it, because this only works if it's at scale. If you've only got one honeypot that's sitting there, or honey cluster sitting there, then that's not going to get the intel that we need. So if we jump on to the next slide, this is where we need this free open source threat intelligence. So if you've done any threat modeling, then as I mentioned, you get this thing where you've got the tree there that comes along, where you can then go through the nodes, and those nodes can be and, or they can be or, and then you can work out what are the critical ones to get that attack moving all the way through. There are there are sources of information out there already. The one from Wiz is particularly good. At one point, I worked for a competitor of Wiz's, and when they released that, it was infuriating. So you're like, oh, that's really good. Oh, I wish we'd done that, and we didn't. But so it's genuinely, it's really good information, and it's got a lot of information about what's actively being used and getting information from that. So you're not just looking at a list; you're looking at this is what we're seeing in the wild at the moment. So it's really good. But that's it. So if we want to then verify and quantify that, it's quite difficult. As I said, it's a lot of gut feel. So this is the four main pillars, and it's like me reading out bullet points for you. But you generate the threat model, you generate that attack model, you work out what that critical attack paths would be. So when we've got that tree, we're then looking through and going, okay, what does the most damage? What are the things that I really actually care about? If we then create this honey cluster, then we make sure we've got lots of nice tripwires in there, and we put some nice tasty bait, and then we baseline. And then we baseline. I did cover the tripwire. That's exactly right. The security works. But then we baseline it, so we're able to say what's normal activity for that application. Can't believe I've broken it. Yay! So we baseline it. We remove what we see as normal activities. We duplicate all of that, and then we disseminate the threat intelligence. So quickly before I lose the TV again. So this is what we've put together, and in really, really dark there, you can see we've got a repository on GitHub. Some cheek over there from the CEO. We've got this repository on GitHub where we're doing it, and it's got some information around it for the different tooling that's being used, and all of these are designed to try and make it easier for people to consume. So instead of having, we're using eBPF, which is what it's nice and lightweight, so we can deploy this easily because we want folk to be able to do things without damaging their clusters. We've got Tetragon there to try and make that easier. We've got all the different parts of it, and including the WebAssembly there, in order to be able to take all the different stuff that we've got from Kprobes and all of that different JSON information, mash it all around, make it all nice, normalize it if you like, but produce what we're calling a schema that we can then load into databases, and that's where we can start doing some fun stuff and actually going, what is going on and how do we make this work? This will be, I should have said at the beginning actually, it was a very, very smart gentleman who works in ControlPlane who delivered this talk alongside Constance at KubeconEU in the EU. And the recording's there, and in fact, Wiz were kind enough to put out of their most interesting talks that they'd seen. They labeled that one as the first one that they put out there. But the reason why I mention that is because it's about 40 minutes long. It's two people who are theoretical physicists by training, who are now doing lots of cool stuff in cybersecurity. So it's really interesting. And they really go into the detail and tell you stuff, as opposed to a CTO whose job is just to talk and kind of wave his hands about a little bit. But this is why this is a lightning kind of talk. Have I done it again? I didn't touch it. I didn't touch it.
No, it's the battery.
It's the battery. So, well, it's a good thing then that it's
It's battery.
It's a lightning talk. So anyway, yes, so that's what I'm saying. It's a lightning talk. They go through full demos in that, so you'll be able to see the actual demos. I've not got any recordings. I'm not going to run any of the demos. I definitely don't want to touch anything again because I'll switch it all off. But all the details are there. And the point being that this is something that's designed for you to be able to pick up and run and try. Okay, let's go to the next slide. Of course, the difficult part with all of this is actually that looking at what's normal behavior and what isn't normal behavior. So you need to spend a little bit of time working out what's your application doing. In the GitHub repository, there are a number of different ways that we've come up with to try and help with that in order to be able to look at what the normal activity is, and then being able to exclude that when you're actually running the live honeypot. Now, of course, if you're going to run a honeypot where you're deliberately letting people do bad things, please do so responsibly. We're not trying to say that you should go straight out and do this without thinking about it, but when I come to the end of the talk, I'll try and say why we think this is a good thing that you should carry on, and why we're giving this and talking about it to raise that awareness, to try and encourage people to look at this. Okay, let's jump over to the next slide. So this is basically the overview of how we've got things set up. You've got an organization. They're the ones who are going to run the different honey clusters. Again, we're providing the code for that. You're going to see those observed events, which are then going to go to this open source threat intelligence database, which is what we can then share out so that everyone can see what the actual live attacks are. And so for all that threat modeling that's happening, you can see these are the tactics and techniques that are being used. This is actually what we're seeing live from all these different organizations. This is the reason why we want to make this as accessible as possible, because the more people running these, the more information that we're going to get, the more that we can share out. NCSC advised the use of Sticks and Taxi. Sticks is a slightly old and slightly complex, but actually maps quite well with the different areas that we want to use. Oh, Lev, go and just sit here and wiggle the mouse every so often for me, would you please? Just doesn't like me. And then, I mean, there are other standards, as we said there, which you can all read, so you don't need me to go through it. But actually, we did find out that Sticks works very well with what we need. And if we go to the next slide, you'll see that it's overlaid quite well with the different Sticks domain objects. So we can see that an organization would map to an identity SDO. We can see that then when those events are coming out, they would tie nicely into a sighting. And then we can actually use that to layer on top of not just the observed real things that are happening, but also over onto our theoretical attack trees. So we can actually layer from the real life and all the data that's coming through. We can go take that back to those different parts and follow that critical path across all those different nodes, and then work out what the actual things that are being used. With me so far? And actually we can do an awful lot of playing about, because when you look at the references coming in and the observed data SDO, we can use that as an indicator for the nodes, and it all feeds back into each other. All right. Or maybe try Andy's one. That was quite successful, I think. So why do this? Why look at it at all? I mean, if people are aware that there are many different types of these honey clusters running, then potentially that's going to cut down on attackers anyway, because they actually know that they're going to be triggering different things. Hopefully, if we've got all these different clusters running, then we'd be able to get that information of there is a wide-scale attack that is happening now. This is the new stuff that people are doing. These are the attacks that are running, which is really exciting. And having that information available across different organizations, that really means it speeds up that whole time to react, the mean time to fix, all of these different things come together because of the scale. And then also that independent quantification of attack paths. So even if you were just to be using this to be able to say, we think that this is the threat, these are the threats, this is the attack vectors that we need to care about, you're able to check and have confirmation that, well, actually that is what's being seen. It's no longer this theoretical, I think it's going to be this because I saw that in my career at some point. Instead, it's no, this is live information that we've got. These are the attacks that are happening, and you can see that. And then in the future, how can we see this? How can we see this developing? Well, obviously, this all depends on the community and getting community involvement and trying to build up some of this energy around it. But if you think, actually, what we've got written is I mean, it's a free intrusion detection system because, of course, that's what it's written to do. So actually, if you wanted to try and use that, you could have an IDS for free, hooray! And it's very, very quick and very, very lightweight because the whole point is we want people to be able to deploy this easily and be able to run it and get the information. You should be able to quantify your own threat models. I mentioned that in the last slide. So you're able to look at the threat models you've created and work on that. But then also, and I get quite excited about this because, well, as that C-level, I get to go, oh, is it people, process, or technology, and work through all of that. But I get excited by the people. And I think, that doesn't sound right, but I think that actually doing threat hunting in your own organization or enabling your people to be able to start approaching that is great. And if I can switch the screen off for a minute so I've got more freedom to talk, that would be good. Yeah, and then actually, so that's the spoke side of things. But the global threat intelligence database, really, at the moment, because it's designed to be, and I go on about this, but this is kind of where the magic is, because it's consumable, because it's easy to use, and because it's wrapping all this data up, it's deliberately staying away from trying to say, and we'll do machine learning here, and we'll do AI here, and it's all the bells and whistles. It's not simple, it's easy to use. But actually, the development aspect from that is then with all this data, then you can start doing fun and exciting things or whatever the new stuff is, because we've got data that's in a standardized format that we can query, and that's where I think things could spark off. And then, interpreted by experts who are doing live streams. Okay, next slide, please. So, why support? So this actually, amusingly, the first time I got introduced to this was where I was being pitched as to why I should support this at ControlPlane. The support pays off because I think of all the different information that we've already been giving. But in the next slide, not next slide just yet, but in the next slide, just to give you a preview taste, we talk about some of the stuff that's going on. But how organizations can support. You can sponsor. You can sponsor. You can contribute yourselves. You can sponsor. We can get developers to be operating on this. If you've got infrastructure, run these honey clusters. Make sure you do it in a safe manner, but run them and get that telemetry. Get the information. Let's jump over to the next slide. And there you go. Lightning fast. But thanks very much for listening. Liv, who's right here, did all the graphics, so that's fantastic. I did. Andy might like this. Amusingly, when I got these slides, it said thanks to everyone and Andy Martin, and then it said and Ashley Ward, and I went, oh, I didn't have anything to do with this, but I guess I got pitched, so that's it. We're funding this alongside. Anyway, it's the last little bit. Why are ControlPlane involved? We think this is really exciting. We often, through all of the different things that we do, we like to contribute back into the community. We also think that having this type of information will reinforce all those threat models that we do. We've got the experts who can go through all of that, and having that quantifiable data to back it up, we think that's incredible. So please do get involved. Use the GitHub links there, and yeah, that's a very quick overview. All right, I'll get the applause. I feel good about the applause, and then I say, and are there any questions? Well, you better have a question, Neve, if you were the one that saying that I need to do questions. Is it my accent? No, so, oh well, any?
How can people get involved if they want to?
That's a very good question. So we do, I mentioned GitHub, you see the link that's there. There's also a Slack channel to get more involved and start, really the community is getting built through that. I suppose I should probably try and find it and stick it on.
Is there also a weekly Zoom meeting on Friday mornings UK time?
I believe that there's a weekly Zoom meeting on Friday mornings UK time. There you go. So yeah, but it's really something that's very active. It's something that we're trying to encourage. So we're fully supporting it.
What's the name of the guy talking to?
It was JC, James Callan, and Dr. Constance Rowe. I can't pronounce her last name, so I'm not going to try. I'm afraid. Dr. Constance, but it was at the beginning. Yeah. But as I say, so even the way I found it today, we put it out in our blog post, but a quick search was KubeCon Top Talks. It's the first one that comes up. Alrighty, well, thank you very much. What are we doing? 5 minutes?
5 minutes, and we're back.
Plugging in.
I don't know.
Or changing the power settings to make sure it doesn't go to sleep after 5 minutes.
Yeah, I mean, normally it doesn't do that. I don't know.
How much battery does it have?
It's got 37.
Yeah, if you go to battery settings, I think you can prevent it from sleeping.
I don't know why it never does this. I'm in meetings for like an hour and a half, and it doesn't do this.
Battery.
Battery.
Yeah, so.
Screensaver.
No, it's under options of battery. I think it's one of the power savings.
Power savings.
Try the options button on the
Options.
yeah. So prevent automatic sleeping, wake, slightly dim. So there should be a setting which defines how many minutes the screen is on when it is on battery.
I mean, it's not plugged in. General?
No, it's usually on the power and the battery.
Bloody MacBooks.
I think they changed it. It should be somewhere in there.
Slightly dim. No. Screen wallpaper displays. True tone.
No, it's not screen saver. It's a power thing, not battery related. Could be under general, maybe somewhere. But yeah, if you try power as a search.
Power nap?
It's close, yeah, some of that.
Turn off display
Yeah,
when
that's
that one?
the one. Yeah, that's the one.
Never. Wahaha. Thank you so much.
Really old and
Oh, that was so good.
It's time.
Welcome back. And for this evening's headline act, the grand finale, Mr. Yannis Folias talking about untrusted binaries in your cloud-native supply chain.
That's me. Right. Let's make it start. Wait, I'm making this. Yeah. So yes, what this talk is going to be about, we're going to be exploring the risks of running insecure binaries in supply chain, actually. We're going to have to understand the actual problem and the actual impact of this problem. and we're going to be discussing actionable strategies, and we're going to be taking a slightly hands-on approach on resolving this issue. Hopefully, we're going to have some time for like Q&A and stuff like that. So yes, who am I? My name is Yannis. I'm a security consultant with ControlPlane. I'm focusing on assessing the security of cloud-native environments, mainly focused actually on supply chain security and threat modeling, a dedicated father of 2 little cheeky monsters, and I'm really passionate about football and good food. Actually, great food. Yes, story time! Whee! Yeah. Let's keep moving. Yes, during my early days of ControlPlane, we started working on a customer who was like a very challenging environment, actually. Yes, and yes, once I started looking into the Docker files, I saw something like that, which was, it doesn't really look suspicious or anything malicious, but still, I started asking, what is that? And what is the source of the binary? Do we trust this source? Is it up to date? Has it been scanned? Was it signed and verified? Does it have the appropriate permissions? Have you spent some time actually investigating what it's doing? And the answer was no to all of these questions. That's a lot of questions, indeed. However, we're going to have to consider the potential impact of this simple binary, let's say. One sec. This could lead to a potential container compromise. What this means is actually it could allow an attacker to escalate privileges or even escape the container. It could allow the attacker to attempt to move laterally and get access to a more privileged container within the environment. It may even start extracting, manipulating, and detecting, deleting sensitive data. It could even get access to tokens, any sort of API keys, or maybe even other environments. And of course, it could affect the entire workflow and the supply chain. Speaking of software supply chain, so this is how the typical supply chain looks like. We've got like the developer who's pushing code to the source. The code is getting built, then packaged and deployed, all the way to the cloud environment. One of the issues that, the potential impact, let's say, when the developer pushes code, is to submit something malicious. And why are we talking about this? Because actually, a binary could sort of force the developer to push malicious code. Also, a binary could actually extract the SSH keys and get access to the source code. It could even manipulate the approval process, which is, yeah, it's quite serious. Looking at the actual source control, it could even like, if we have a binary which is like vulnerable to, it has like specific CVEs and stuff like that, it could even get compromised. It could even like inject a malicious plugin. I can think of a plugin like there is something like a Sonar Cube running, and what if it's out of date? What if like it has some CVEs? What's going on there? Does this communicate with anything externally? It could execute a malicious workflow and maybe output to. Actually, I want to clarify something here. I'm talking about log output to unauthorized destinations because actually most of the source control systems, they have some sort of, let's say, variables to output logs to specific destinations. If someone manages to manipulate this is where the issue begins. Loads of slides to go through, sorry about that. Yes, moving on to the build process, a binary could even assist in exploiting the build server. It could manipulate it, like the build pipeline, As an example, I could think of like Jenkins files getting manipulated and doing something nasty, which would not be nice. Also, as part of this process, maybe it could inject some sort of malicious code, a malicious script or something. Whether it's a simple command or maybe like a slightly bigger script. Yes, we have an authorized build out, but however here, it's not so much about the log output. It could even output some sort of an artifact towards unauthorized destinations. And also it could tamper with the build artifacts. Tampering in terms of what? This is where actually the next process starts to review. We're talking about repository compromise. Maybe even deploying secure packets. And yes, possibly a binary could affect the signing and verification process. So if, for example, binary manages to like, how can I say that? Maybe inject its own signing keys or signatures or anything like that, it would be able to like authorize something that shouldn't be authorized. Last but not least, it should be able to extract any environment credentials and maybe get access to an AWS environment and start speeding up like anything. So we have to do something. This should be working, by the way. It's not working. This lady is supposed to be moving, but she's not. Yes. Anyway, that's fine. Let's go to the next one. So we have to be proactive and do something about it. One of the first things we have to do is like adopt a zero trust security model. This is going to be the basis of whatever we're doing next. We're going to have to restrict access to resources and whatever developers can access and may download from. What I'm writing here, like downloading from single trusted source. I'm not sure if that's possible. At least we should be able to restrict the amount of trusted sources and take it from there. We should be able to implement network segmentation and isolation. Yes, this is a big one because, for example, in our days, there's no excuse for a dev environment, for example, being able to access staging or prod or anything like that. Yes. Also, we have to implement the appropriate monitoring, something that would give us the ability to like detect anything as soon as possible, as soon as it happens, actually, and have the appropriate alerting in place. So yes, as part of being proactive, we have to create like an incident response plan because this would give us the ability to, as I said earlier, identify the issue on the spot, contain it, and maybe recover from a disaster or something. We should be able to recover the system to its previous state as soon as possible. Right, so last but not least, and I think it's by far the most important thing, we have to invest in security training and awareness. What I mean by that, I know that most developers are getting bored. They don't really like having training on these things. However, we need to make them start thinking about best practices, about how to use tools appropriately, and consequently, where to download tools from. On a more practical note, we should be able to investigate any sort of binary before it even gets to any environment, whether it's dev or our own laptop. So there are mainly two ways to do that. One of them is via statistical analysis, which means actually executing code, understanding what the binary does without executing the code, and how we can do that. We can start by actually fuzzing in a way. We could input this specific binary into the disassembler and start going through the registers and understanding the control flow. look for any strings, any API keys, any passwords, any links. I don't know, anything. Anything could be there. Last but not least, pass the binary to the debugger, so at least we could go through each step of the execution and understand exactly what it's doing. I'm going to say that again. It has to be in a sandbox environment, in a controlled environment where there's not going to be anything else there. There is something here which says, does this sound like a plan? No, it doesn't. No, rejected. As Francesco says, denied. Why is this denied? Because it's really hard to automate the static analysis bit. It's really hard to do that. That's why we should be looking into dynamically analyzing the binary, which means run it. Yeah, this guy is supposed to be moving as well, but he's not moving. Let's move on. Yes. So in order to start analyzing the binary dynamically, we have to create like a sandbox environment. In this specific instance, I'm creating a Docker container, a gvisor Docker container, which is a sandbox container with restricted access to the host. And yeah, the only thing I am adding is this capability here, which allows me to do some, to trace actually the system calls that something is doing. So one of the first things we have to do is identify any suspicious systems code. The best way to do this is using systhreads. Another way, actually, yes, not the best way, an even better way is using a tool called tracing, which provides like a whole different level of abilities to do that. So we have to look for file system operations, inter-process communication, any privilege escalation terms. For example, on this specific one, with the privilege escalation, we should look out for any sort of attempts to use any Linux capabilities. There are plenty of ways to escalate the privileges via Linux capabilities, but that's not the subject of this specific talk. It could even do some memory mapping. Wait. So as a next step forward, we should be able to identify any attempts for external connections, identify any usual patterns, or non-standard protocol usage. I remember back in my OCP days, we used to do like lots of stuff with UTP. There were services running in UTP instead of TCP, and everybody was spending so much time to find what the issue is. But yeah, I guess they're still looking. Yeah, one of the problems with UTP, for example, is that it's extremely slow compared to TCP. What I mean by slow is when you're trying to go through and actually scan a specific host or a network for UDP services. Also, we should be looking out for any unexpected open ports. LSOft, for example, is a very good tool to look into this. As I said earlier, we have to look out for any external API calls or libraries, any abnormal resource consumption, any sort of spikes, any CPU usage spikes, any RAM usage spikes, or anything like that, and any unusual patterns in general. So, as an additional way to verify the actual binary, we should look into whether there is any SBOM in the source of this binary or any provenance data. This would help us further verify who actually the actual components of this specific binary and who built this binary when, and all that kind of beautiful stuff. So, go back. Yes, and valid. Oh, sorry. Please keep moving. What if? That's the big what if. Please. Yes. In some cases, in most of the cases actually, the source is not going to be providing any SBOMs or provenance data or anything. So the big question is, what do we have to do in this case? From my perspective, someone else might think otherwise, but what I think is we should be building from source. In this process, the first step is going to be clone the repo of the actual binary, build from source, inspect the binary in a sandbox environment like earlier, generate, sign, and store the SBOM ourselves. Please go back for 1 sec. Yes, I'm doing this using cosign. This is an extremely useful tool for this purpose, which also publishes the artifact and the signature to the repo on the other end. Yes, we also need to generate, sign, and store our provenance data. In this specific instance, I'm using Witness for this purpose. Witness is a very, very useful tool which is used to generate in total attestation data for each step of the build process, which is, I can't stretch this enough how useful this is. Where are we? Provenance, yes. As a next step, we have to scan the SBOMs for any CVEs, to scan each individual component for any CVEs. As we can see here, for example, I'm scanning, I go to a repo of the internet, and there is a binary. I built a binary called calculator. And as you can see here, there are specific CVEs. It's where there's critical high. And we should at least address the high and critical ones before going any further. Yes. After scanning the SBOM, we should actually, what I mean by artifact here is about containerize the actual application binary. We should sign it and then publish it. And of course, we're going to have to verify the artifact before we use it into the Kubernetes environment, for example. And since we're talking about Kubernetes, for example, one of the most useful tools out there is to use like an admission controller and actually validate anything that's coming in, whether it's been signed, and the attestation data and all that kind of beautiful stuff. That's pretty much it on my end. Any questions, any thoughts, any feedback would be much appreciated. Actually, I changed my mind. No questions. That's it. No, just kidding. Yeah. Any thoughts? I'm just going to sit here for a bit. That's fine. I'm an old mama, so.
Will a container security scanner like Trivy able to catch all the SBOMs rather than compared to building from source? Or?
I'm not sure. Actually, no, because Trivy is not going to catch anything related to a binary. It's going to catch anything related to the actual container. Yeah. Because actually, can I just say something in addition to this? We need something to investigate the actual dependencies of the binary and how the binary is built. And I don't think that Trivy, for example, is going to be able to disassemble, let's say that this is the right word, disassemble the binary, identify the right dependencies, and then say where, are they vulnerable or not? So, yeah.
Yeah, but disassembling, as mentioned, is a bad strategy because it doesn't scale.
Yes.
So
yes.
Instead, we just, you can only do dynamic analysis in your case if you have the source code, right? So you actually rebuild it. But what if you don't have it? The only option is to...
From my perspective, we should reject them.
Okay.
We shouldn't be using anything that can be verified. Because, I've experienced this myself, a binary stuff doing like nasty things, and it wasn't nice. Because back in the early days of my career, I was working on behalf of a hotel. And when this started affecting the actual rooms, for example, and the clients of the hotel, they were extremely unhappy with whatever was happening. This is where everybody started screaming at me. And this was just because I was using a specific, I used a specific binary to do something. Yes, and from my experience at least, we shouldn't be using anything that can be verified. Maybe that's me. Other people might say, because actually I was having this discussion with someone earlier, and yes, but he said, we're talking about something ideal here, and the world is not ideal. I'm totally with him. He said we should be able to accept the risk up to a certain level. And I said, anyway, I still wasn't sure whether I'm with him or not. I think we should still, in an open source world, for example, we should be able to verify whatever we are using, at least. Yeah. Let's say we're using Trivia, for example. Shouldn't we be able to verify where this binary came from? Was this signed? Who created it? And when? So this is what I mean. I know I'm going to have a lot of people who don't agree with me on this side. And they're going, oh, come on, it's just a binary.
I think you were quite right, though, to mention that around, okay, but then if you want to be risk-free or risk-free, but if you want the lowest level of risk, that's what you want to do.
Yeah.
If for whatever reason, reasons you have to accept something else, then that becomes that how are you mitigating that risk, and how do you accept that risk into your environment. So I think you're perfectly valid by saying, well, this is the ideal.
Yes.
And then this
at the end of the day, you know what? As a consultant, not just me, everyone, we're making a lot of suggestions. Let's say it's up to the client whether they're going to adopt these suggestions or not. We can't force them or anything. At least on my computer, for example, yes, I'm doing these things. Yeah, so that's pretty much. Yay! What? Hi, Sia.
Well, thank you very much to our illustrious speakers this evening. Thank you to everyone who's turned up, and thank you to everyone live streaming. We're going to the pub down there. For those of you within the facility, please do join us. And thank you to DevSecCon. Thank you to everyone who's helped us to organize, and all the speakers, and everyone who's attended. Have a wonderful evening. Good night.